So as you can see here, today's lesson is going to be about drawing triangles. And what we're really focused on today are what are sufficient conditions for drawing a triangle. So that's just a fancy way of saying what conditions will allow you to draw a triangle and what conditions will not allow you to draw a triangle. So take a look at this slide here. So the first thing I'd like you to think about is side lengths. Can a triangle have any side lengths? Are there any combination of side lengths that would not allow us to draw a triangle? And if so, what types of side lengths would not allow us to draw a triangle? So you can see how I have this little clip art thinking guy there. I want you to think about it for a bit before you move on to the next slide, or before I move on to the next slide. So I'd love to have you pause the video. Think about that for a bit. Are there combinations of lines that would not allow you to draw triangles? All right, so I'm hoping that you did land on the fact that you can't always draw a triangle. All right, so in fact, we're going to actually go to a website where we can put some different side lengths in and see if these side lengths will allow us to draw the triangle. Okay, so here's the tool I was talking about, and you can see that it's from Math Warehouse. It's called Online Triangle Calculator, right? And what we're going to do is we're going to scroll right down here. So what we're going to do is we're going to put some side lengths into this calculator. All right, so let's just do one for sure that we know will make a triangle. So we've done some before with lengths of 3, 4, and 5. All right, and it tells us, yes, successful, able to create a triangle. Okay, in fact, if we look, here is a triangle right down here with lengths of 3, 4, and 5. All right, so what I'd like to do is I'd like to maybe change some of the conditions with just the longest side. So watch what you can do with this calculator. You can just increase it by 1. All right, so there's a 3, 4, 6 triangle. Do you see what's happening here too? The angles are changing, so it's telling you what the angle measurements must be. Eventually, you'll get into some math classes where you yourself will be able to look at triangles like this and do a few calculations to figure out the angle measurements. This is nice though because the online tool is doing it for us. All right, so when I hit the up button, we know what's going to happen. It's going to go up to 7. All right, so I want you to think right now, well, what's going to happen when I make that go up to 7? All right, well, here we go. Oh, whoa, wait. Okay, we're getting a big X, aren't we? We can't have a triangle with the shorter sides being 3 and 4 and the longer side being 7. Right? That's just not going to work. So think about that for a second. Why wouldn't that work? All right, well, if you had one line that was 3 and another line that was 4, how much would that add up to if you added them up? Oh yeah, that would be 7. So if you have a side length of 3 and another one of 4, you can't make a triangle you can't make a triangle out of those sides because the two smaller sides are just going to land on top of the larger side. What if we made this go up to 8? Well, of course, that's not going to work either, right? Right, and if you look here, it says something about the triangle inequality theorem. We're going to talk about that in just a minute, but let's do this. Let's make one of these smaller sides go up. All right, so now I've got sides of 4 and 4. All right, well, 4 plus 4 is 8. So again, that's just going to lay like right flat. It's not going to make a triangle, but what if we make this go up one more? Ah, there we go. We can have a triangle with sides of 5, 4, and 8. Right, so my question is, do you see any pattern or is there any general statement you could make about that? All right, so think about that for a second while I go back to the slideshow. Okay, so I already said this, the sum of any two sides of a triangle must be greater than the third side, right? And I'm hoping that makes sense if you think about it, because if it's not, it's just going to either lie flat or the sides won't even connect. All right, so there's a name for this. It's called the triangle inequality theorem, and we're actually going to visit this website ourselves to talk about this theorem. I think I mentioned in an earlier lesson, or you watched in an earlier lesson, how postulates and theorems are part of geometry. So a theorem is something that we can prove. We're not going to work on proving it, but this is important just to know, even though we're not going to go to the trouble of proving it. I bet you could figure out why this works. So the question is, can any three side lengths form a triangle? All right, we already know no, that can't happen. There's a little tutorial here if you want to watch it later. So here is the triangle inequality theorem, though. What this says is that the sum of any two sides must be larger than the third side, and it has to be true for all three conditions. So it has to be like A plus B has to be bigger than C, and B plus C has to be bigger than A, and A plus C has to be greater than B. So the sum of any two sides must be greater than the third. All right, but here we go. All right, here's a situation. We have one side of 10, we have one side that's 4 and one side that's 3. And I think you can see that if you tried to make a triangle out of this, you're just not going to be able to do it. Well, here we can see, well, 10 plus 3, of course, that's greater than 4. 10 plus 4, of course, is greater than 3, but 4 plus 3 is not greater than 10. So that is not going to be sufficient conditions for a triangle. All right, now the next question is, do we always have to check all three sets of numbers? Well, think about that for a second. Do we really need to check all three sets of numbers? All right, well, let's see what this website says. No, yay, okay, because what a lot of work that would be. All right, you only really need to see if the two smaller sides are greater than the largest side. So if you look at the problem back above, all right, the 4 and the 3 are the smaller sides. This is really the only one you needed to check. So the way I say it is, the sum of the smallest two sides must be greater than the longest side. You really only need to check that one. So that's a nice thing to know. All right, so this would be a condition that is needed in order to actually draw a triangle. All right, so that's what we mean by conditions. All right, let's take a look at the next slide. All right, the next thing is angle measurements. All right, we've talked about this a little bit before, but let's talk about it again. Can you draw a triangle with two obtuse angles? How about two right angles? All right, well, try it and see. All right, I'm going to show you my attempts next. All right, so here's my attempt at two obtuse angles. Of course you can't. All right, you can have one obtuse angle, but then in order to connect the third side, these two would have to be acute. All right, same here. Right? In fact, if you have an obtuse angle, your acute angles are going to be pretty small. Right? Remember that the sum of the three angles in any triangle must be 180 degrees. Right? So this, if it's an obtuse angle, is going to be greater than 90. Well, if you think about that, then the sum of the other two angles would have to be less than 90, because 90 plus 90 is 180. This is more vivid here. Right here, this was my attempt at two right angles, and really my attempt was more learning how to use the drawing tools on Google Slides, which I had fun doing. But all right, back to this. So here's my attempt at two 90-degree angles. Well, you can see you just can't make a triangle. All right, this would have to be, folded down here. All right, but if I did have one right angle that's 90 degrees, if I did connect this, think about this for a second, my other two angles, if I added them together, would have to equal 90 degrees. Why? Because the sum of the angles in a triangle is always 180. 90 is half of 180. Right? So if this one's 90, the sum of the other two have to be 90. All right, I hope that makes sense to you. All right, let's take a look at this. We're going to talk about congruent triangles versus similar triangles and talk about the symbol. This is from the Math is Fun website. So basically, what they're saying here is congruent triangles have exactly the same three sides and exactly the same three angles. Right? The equal sides and angles may be in the same position, all right? Or they can be in different positions, all right? So basically this triangle is congruent to this one because the sides are 4, 5, and 7. It doesn't matter what position it's in. It's also congruent to this one. These two here, not congruent because the sides are different. As soon as the sides are different, it's not congruent. Okay, so that's kind of an easy thing to remember. So congruent triangles and congruent figures in general have to be the same size and the same shape. All right, so right here, this symbol, again, we've talked about it before, but this symbol is an equal sign with a squiggly above it. That means congruent, and that means those two figures are exactly the same shape and size. You do have to make sure that when you're saying it, the pieces that match up are said in the same order. So I'm going to go with the smallest angle, next angle, next angle. By the way, see how there's two little curve marks here on B? That means it's the same as E with the two little curve marks. This one, C with the 3, is the same as F, right? That's going to be important because if I say triangle ABC is congruent to, I have to basically say the corresponding parts. So since I started with A and then went to B and went to C, over here I'd have to say D, E, F. Okay, so I could say triangle ABC is congruent to triangle DEF. I could also say it this way, triangle BCA is congruent to triangle EFD. It's just that I have to keep the parts that are the same measurement together, or what you would call the corresponding parts together. Right? Hopefully that made sense. I think the really important thing is get that congruent symbol down. Again, it doesn't mean equal. Anytime we use the term equal, we're talking about numbers in mathematics. About shapes, if they're the same, we're going to use the term congruent. Right, similar figures are the same shape, but they're different sizes. Right, so the thing is, in fact, we're going to look at this site. The thing is, they're also going to be corresponding because they're going to be in specific ratios. I bet you can see that looking at this, right? But let's go to this website first. Okay, so this comes from Math Open References, and I love this because you can actually drag any orange dot you want, and one triangle will stay similar to the other. Isn't that cool? All right, I just love that. All right. Yeah, you can't make it go off the page, but if you want to play around with this yourself, just go ahead and visit the website. It's I hope you can see the address there, but you can move any one of them, right? And these triangles are staying similar. Right now, while I'm playing around with this, I want you to notice what happens to the angle measurements, okay? And by angle measurements, I mean this one that has 1 tick, this one that has no ticks, and this one that has 3 ticks, right? What happens to them? Right, they're not changing, right? They're just not changing. So what we've got here is the angles in similar triangles are going to be the same. Right? The sides are different, but the angles are the same because they're the same shape. So triangles can have the same angle measurements, but be different sizes. If that's the case, we're going to call them similar. Same is true with quadrilaterals. Quadrilaterals are 4-sided. The measurement of the angles in quadrilaterals always adds up to 360, but they can be very small or very large. Like you can have a very small square or a very large square. You still have 4 right angles. So it's still 360 degrees, but they can be different sizes, meaning that they're similar. All right, that's kind of cool. All right, so I want us to take a look at this real quickly. You can see here, 1020, 1428, 1632. Another thing about similar figures is the sides are in a specific ratio, and it's going to be the same for all of the sides. Also, the symbol for similar is just the squiggly sign, no equal. All right, last but not least, I want you to look at this. Are there any similar triangles here? So pause the video and see if you can figure out whether there are. And I hope you figured this out. Yes, there are, right? So the fact that DE is parallel to AC makes this angle equal to this one and this to this one, and this is the same, right? And then this one, these triangles are similar. Note they're the same distance apart. Right, so just think about them for a bit. All right, nice work.